This lesson is about redshift and evidence of the Big Bang, and by the end of this lesson you should be able to explain redshift in terms of the expanding universe and also explain how redshift and other evidence can be linked to the Big Bang model. So before we start, pause the video and have a go at these 3 retrieval questions. So hopefully you remembered that the colours of the plugs, which is what we did in the last lesson, was the neutral wire is blue, the live wire is brown and the earth wire is green and yellow. And the order of the magnetic spectrum looks like this. So this is an order that you need to try and remember. So we've got gamma, X-rays, ultraviolet, visible light, infrared, microwaves and radio waves. We can see that this is going in order from the highest wavelength, the highest frequency, down to the lowest frequency. And also, of course, that will mean that it is going from the shortest wavelength to the longest. And so it's really important that you have these two in line with the colours. So the visible light, if we're looking from the shortest wavelength, is violet, indigo, blue, green, orange and red. So red has a longer wavelength than violet light, and it comes just in here, so we can see that the red is next to the infrared and the violet is next to the ultraviolet. And the last one is the types of colours that are the best emitters and the best absorbers. And so black is the best emitter as well as the best absorber, and white is the least best at absorbing and emitting radiation. So in this lesson we're going to look at 2 pieces of evidence that show that the Big Bang theory is correct. And the first one we need to look at is redshift, and then we're going to look at background microwave radiation. So if we consider the picture below, we've got 2 people observing a star from different sides of the universe. And if we look at the light which is coming out from the star, if that's not moving, then the wavelengths coming out would not change. They would be the same in both directions. Now, if that particular body starts to move, we can see what happens to the wavelengths. And so we can see here that if we've got a wave that is moving towards you, we can see that the wavelengths are starting to shorten. If, however, it's moving away from you, you can see that those wavelengths are starting to increase. And basically, if we think about the colours of the rainbow, as we've just said, if we have a shorter wavelength, then we're going to be shifting towards the blue side, so towards the blue side of the spectrum. If our wavelengths are larger, then we're going to be moving slightly towards the red, and that's the way to remember it, is that red has a lot higher wavelength than the blue side of the spectrum. And we call these 2 things blue shift if it's the wavelength is shortening, which means it's moving towards you, and red shift if it's moving away from you, because all of the colours will be shifted towards the red end of the spectrum. And this is what we call the Doppler effect, and we can quite often hear this effect when we listen to anything that's passing us. As something is coming towards us, it will have a really high pitch, and as it starts to move away from us, the wavelength will increase, and so that changes the pitch. And you can hear this when you hear an ambulance going by, and that's what we call the Doppler effect. And so every element that we can see within a star or within a material will absorb certain wavelengths and reflect back others. And so what we can see, if we look at hydrogen, we can see all of the black areas are where that particular wavelength has been absorbed. And again, the one below is for helium. and these are unique to every single element. So when we got pictures back from the Hubble Space Telescope, what we started to see is that these particular elements, we could see that all of the patterns were shifted to the red end of the spectrum. And so this is the kind of thing we were looking at, and this is what we saw. So if you look at the first part of this chart, we've got the absorption lines from the sun. So we can see all of those black areas are where the wavelengths would have been absorbed. And this would be the same element, but from a cluster of stars in a galaxy that were billions of light years away. And we can see straight away, if you can compare these patterns, you can see that the pattern is the same. So we know it's the same element, but we can also see that all of that pattern has been shifted towards the red end of the spectrum. And so again, these were the wavelengths that we were seeing. And this is what we were seeing from our reference point in the lab to nearby stars, to nearby galaxies, distant galaxies, and then very distant galaxies. And what we also discovered from this is that the further away that a star was, the faster it was moving away from us. So we can see again, we've got this whole shift towards the longer wavelength, so towards the red end of the spectrum. So this is our redshift, and this proved that the galaxy must be expanding, and which means if it was expanding, then it had to have started somewhere. So all we can do is roll back time and realise that actually before it expanded, it must have started from a singular point. So the next piece of evidence that we found was background microwave radiation. And this was actually found by accident. Some scientists were looking at the universe and had some very strange readings, so much so that they actually changed their equipment at one stage. And when they shared those readings with other scientists that were looking at the Big Bang Theory suddenly realised that this was the evidence they were looking for. And basically, microwaves, as we know, have a longer wavelength. And so when the universe was first formed, it would have been extremely hot with really, really high frequency radiation. And of course, as that expanded, as we've seen with the Doppler effect, as that universe expanded, these waves were stretched out. And as a result of that, the wavelength would have increased, so much so that we now have microwaves. And everywhere you look in the universe, you can see microwave background radiation. And so this was the next piece in the puzzle that was evidence that the Big Bang Theory was correct. So hopefully that explains redshift in terms of the expanding universe, and also how redshift and other evidence like the microwave background radiation can be linked to the Big Bang model.